Welcome to This Explainer. Today, we're setting the stage for, honestly, a pretty exciting journey into the ultimate data science workspace. If you work with data every single day, you already know the truth. Writing the code? Yeah, that's really only half the battle. The other half is presenting it, explaining the narrative behind those numbers, and making sure it's actually reproducible for your team or the public. So we aren't just going to look at basic coding today. We're going to trace the fascinating evolution of how data pros actually operate, starting from the foundational tool that literally changed everything, right up to the heavy-duty, multi-file industrial environments you absolutely need to manage modern data pipelines.
Okay, let's dive into this by looking at a huge milestone in modern science. Back in late 2015, the LIGO Observatory detected gravitational waves. Just an absolutely groundbreaking moment in astrophysics. But, what's equally fascinating for us data folks is exactly how they publish their processing methods. Before this, verifying complex astrophysics algorithms meant spending months pulling your hair out over static PDFs, trying to piece together someone else's super fragile environment. But the LIGO team didn't do that. They shared their research in notebook form. And wow, this was pure magic for reproducibility. Literally anyone, anywhere, could instantly look at their exact code, tweak the parameters, and recreate those exact groundbreaking plots right in a standard web browser.
So it makes you wonder, how exactly do scientists effortlessly share and reproduce complex data at that kind of scale? Well, the answer lies in the Jupyter ecosystem. Evolving out of the older IPython project, Jupyter fundamentally revolutionized scientific transparency. It allowed researchers, engineers, and analysts to seamlessly blend raw code, interactive visualizations, and narrative text into one single highly expressive workflow. It essentially bridged the gap between a sterile code editor and a finalized research paper. It created a living document where the data could actually speak for itself.
Section 1. Anatomy of a Notebook. The Basic Workbench.
To truly understand this workbench, we got to look at its brain, the kernel. So the kernel is the computational engine operating behind the scenes. When you write a piece of code and hit run, the kernel is the thing doing all the heavy lifting, processing your Python, R, or Julia code. But here is the real magic ingredient. The reason this fundamentally changes our workflow, it's statefulness. The kernel maintains the state of your environment. Think about the massive time savings here. You can load a gigantic, say 50 gigabyte dataset into memory just once, and then spend hours playing with it, filtering it, running calculations, all without ever having to reload that massive block of data from scratch.
Now, if the kernel is the brain, the cells are the body. A cell is simply the core building block where your code and markdown reside. But for advanced users, cells represent a complete shift in how we approach problem solving, and it's all thanks to the read, evaluate, print loop, or REPL. Instead of writing this massive top-down script and just praying it compiles perfectly at the end, you execute nonlinear chunk-by-chunk logic. You can isolate one tiny data transformation, run it, see the output instantly right below the cell, and iterate. It completely transforms debugging from this tedious hunt for errors into a really intuitive, interactive conversation with your data.
And beyond just simple text and code execution, this environment is absolutely packed with features that eliminate workflow bottlenecks. Take magic commands, for instance. By just dropping a command like %timeit into a cell, you can instantly profile a slow-running pandas function and optimize it right on the fly. You've also got inline plots, which means your matplotlib or Seaborn visualizations pop up right there in the document. And this brilliantly illustrates how dynamic the workflow can be. Because your plots render inline, you never lose the visual context of your data transformations. You aren't endlessly alt-tabbing between your code editor, a system terminal, and some external image viewer. Everything is just right there. Now, the classic notebook is undeniably fantastic. But think about what happens when your projects inevitably get bigger. Because they always do, right? What happens when you aren't just writing a quick script, but you're managing massive, interconnected data pipelines? Just picture this scenario. You suddenly have 15 different notebook tabs open in your browser. You're totally losing track of which kernel is attached to which data set. You desperately need a system terminal running a local server. Oh, and you need to inspect a raw CSV file. Yeah, the single-track nature of the basic notebook begins to create some really intense friction here. Your cognitive load skyrockets, and you realize you have completely outgrown the basic workbench.
Which brings us to Section 2. Enter Jupyter Lab, the industrial workshop.
So that friction brings us directly to Jupyter Lab. And let me be clear, Jupyter Lab isn't just an aesthetic upgrade or a fresh coat of paint. It's a complete structural overhaul built specifically to handle the chaotic reality of modern professional-grade data science.
It provides this modern, advanced interface that wraps around the core interactive notebook, but with an architecture designed for ultimate flexibility. I mean, it's engineered from the ground up to handle multifaceted, multi-language projects without breaking a sweat, ensuring that power users can orchestrate really complex workflows without constantly fighting their own tools.
Let's break down the features that actually turn this into an industrial workshop. First off, you get multiple tabs and split views. Why does this matter? Well, because now you can have your complex machine learning model script open right next to a live scrolling view of your raw dataset. Game changer. Next, built-in terminals. This is a massive time saver. When you suddenly realize you're missing a library or you need to push to get, you just pop open the integrated terminal, run your commands, and keep working without ever breaking your flow. And finally, an integrated extension manager. This solves the scattered tool problem entirely by bringing third-party linters, debuggers, and cloud integrations under one unified roof.
Section 3. Notebook versus Jupyter Lab, the head-to-head.
Now, what's really interesting about this slide is how the direct comparison reveals that both of these tools still serve a very distinct purpose. Looking at the user interface, the classic notebook is simplistic and very single document focused, whereas Jupyter Lab gives you a comprehensive multi-file IDE. When we look at customization and extensions, Jupyter Lab heavily pulls ahead. In fact, its modular extension ecosystem is so robust that entire data teams use it to build bespoke workspaces perfectly tailored to their company's proprietary infrastructure. But don't ignore performance. The classic notebook is incredibly lightweight. Because Jupyter Lab is a heavier, more resource-intensive web app, if you are running on an older machine or you strictly need to execute a super fast, simple task, the classic notebook's stripped-down simplicity is actually a major advantage.
Section 4. Choosing your workspace, finding your fit.
So the crucial point here is really just applying the right tool to the right scale of your project. If you're testing a quick code snippet, maybe profiling a new library, or writing a standalone script to share a single insight with your marketing team, the classic Jupyter Notebook remains your best, most efficient friend. However, when you step up to large projects, when you're managing multiple interconnected data files, requiring integrated system terminals to manage dependencies, and building complex data pipelines, Jupyter Lab becomes the heavy-duty manager that is absolutely essential for your sanity and your productivity.
Which leaves us with one final thought to reflect on as we wrap up this explainer. I want you to take a look at your screen right now. Is your current workflow holding your data science potential back? Are you drowning in disconnected browser tabs and constantly context switching just to get your pipeline running? If you're feeling that friction, the Jupyter Lab Industrial Workshop is waiting to completely streamline your day. But hey, if you just need a clean, distraction-free space to test a brilliant new hypothesis, the classic notebook remains an absolute powerhouse. Evaluate your actual daily needs, choose the environment that matches the scale of your ambition, and let the data exploration begin.